Hey there, fifth graders. Today we're going to take a look at adding unlike fractions. So when our denominators are not the same. So toward the end of last week, we talked about adding like fractions, such as 2/5 plus 1/5. And this was really easy. All we needed to do was to add up our numerators. So this would give us 3/5 and our denominators stayed the same. Today, we're going to take a look at unlike fractions. And the first thing we're going to need to do is create these common denominators. So that's definitely step one, is to create common denominators first. Once we've done that, then we proceed just like we learned late last week, and you guys picked up on it really quickly and really nicely. So remember, to create common denominators, you need to identify a common multiple between the two denominators. Now remember, when you think multiple, think multiply. So if I asked you what's the multiples of 3, you'd say 3, 6, 9, 12, 15, 18. So you think through your multiplication tables. And in general, when you're creating these common denominators, it is the most useful to identify the least common denominator. Now we'll talk about what happens if you accidentally don't pick the least one. It's not a problem. You will get the right answer. It just adds one additional step, and we'll take a look at that on the back side of the notes. So once you've created your common denominators, you've got the green light to go ahead and just add those numerators up, and you keep the denominator the same. So you're just going to add those numerators and keep the denominator the same. So let's take a look at a fairly simple example. I'm going to go ahead and actually start with the 1/2. So I'm going to model half here. And then to that, I'm going to add 1/4. Okay, I'm going to add 1/4. And in total, that has now given me 3/4. So pictures are really awesome. They provide a nice visual for us. However, as we continue to get older, when you get tougher problems, you're not going to want to be drawing pictures for every example. So let's take a look at how we can solve this mathematically without having to draw a picture. So again, the first thing we need to do is create that common denominator. So I'm going to teach you a organizational structure. I'm going to call it the fraction flag. So go ahead and stack up your fractions one above the other. The next thing we need to do is identify our common denominator. And so I'm just setting up my fraction flag here. So my multiples of 2 are 2, 4, 6, 8, ... My multiples of 4 are 4, 8, 12, 16. So the smallest one that I have in common is 4. So I'm going to go ahead and turn both of these into fourths because I can multiply 2 by 2 to give me 4. 1 times 2 is 2. And we already know this. We know that half is equivalent to 2/4. And I'm just going to go ahead and multiply the top and bottom by 1 just so I can stay nice and neat and lined up. Now I'm going to go ahead and add. So I worked my way out, and now I'm going to work my way down with my addition. And when I add, I'm going to add just the numerators. 1 plus 2 is 3, and my denominator stays the same. And some of you might be like, what is she talking about, a fraction flag? Well, if I box this up, it kind of looks like a flag that somebody were to be, if they were walking and carrying it, the flag would be blowing behind them. So this is what I'm going to call our fraction flag, so we stay nice, neat, and organized. So I want to take a look at one of the biggest mistakes that I have seen students make in 6th grade and 7th grade, and I'm sure kids make this mistake even older than that. They think, hey, I can just add straight across. That does not work at all. And in fact, we're going to conclude that's super unreasonable. That's a cow mistake. It's utterly wrong. So let's analyze this last example. If, and that's the big if we could add straight across, we would have gotten 2/6 for this answer. Okay, this is a big if. And I'm going to go ahead and say this is wrong. We already know this is wrong, but let's pretend that this were allowed. Let's think about the meaning of this. So I'm taking a half. I'm taking half of something, and I'm adding something to it. No matter how big or small, I'm adding some additional piece. Your sum is going to be bigger than half. That's going to be bigger than your original half because you're taking half and you're adding more onto it. So you're obviously going to be bigger than half. Okay, I hope that's pretty straightforward. But if you take a look at this answer right here, 2/6, is that bigger than half or, bigger than half or less than half? This is less than half. So it makes no sense. If you're starting with half and you're adding something to it, there's no way that all of a sudden you're miraculously less than half. And that's what we're summarizing here, that 2/6 is less than half. So therefore, this is super unreasonable, like totally wrong. Totally wrong. Let's take a look at some examples. If your answer does happen to be an improper fraction, have no fear. Mixed numbers are here. You just turn it into a mixed number and we're good to go. This is a skill you already have. So let's go ahead and set up our fraction flags. Okay, I'm going to go ahead and just set up the stage for my fraction flag here. Oops. So my least common multiple of 4 and 3, I'll go ahead and skip count by 3s, 3, 6, 9, 12. I'm going to stop there because I know that 12 is also a multiple of 14. So I'm going to go ahead and multiply the top and bottom by 4, and I get 8/12 for the bottom one. 4 times 3/3, that's going to give us 9/12. And now I'm going to add vertically. So I'm going to do 9 plus 8, which is 17/12. So this is an improper fraction. We don't love improper fractions, not as final answers. We're going to divide because remember that's a division symbol. A fraction bar is always a division symbol. 12 goes into 17 one whole time, and there's 5 left over, and that's our final answer. And if you take a look again, we have just created for ourselves our fraction flag. I want you to go ahead and box that up to make sure that you're staying nice, neat, and organized. All right, let's do another example. So this would actually be my final answer, however. 2/5 plus 2/3. Okay, I'm going to set the stage for my fraction flag. All right, so we're looking at 5 and 3. If you need to list the multiples, that's fine. So we have 3, 6, 9, 12, 15. I'm going to stop there because I know 15 is a multiple of 5 as well. So that's my least common multiple. Okay, I need to multiply 3 by 5 to get me to 15. 2 times 5 is 10. I'm going to multiply this by 3/3, and I get 6/15 plus 10/15. 6 plus 10 gives you 16/15, and that is equivalent to 1 and 1/15 because 15 goes into 16 one whole time, and there's 1 left over. And again, I've got my nice and neat fraction flag there, and my final answer here. And let's do one more example, and then we'll take a look at what happens if we don't use the least common denominator. So we have 4/6, 1/8. Okay, and down here for scratch work, I'm going to list my multiples of 6. So I've got 6, 12, 18, 24. I'm going to stop there because I know 24 is also a multiple of 8. So 24 is going to be my least common multiple. I'm going to multiply by 4/4, and I get 16/24. I'm going to multiply this guy by 3/3, and I get 3/21. Going to add these together. I'm going to add my numerators, and I get 19/24. And I've got my nice fraction flag. Okay, let's take a look at what happens if you don't select the least common denominator. That's okay. Any common denominator will do. It will work. The only problem, and I shouldn't even say problem, the only thing is that if you do not select the least common denominator, you're gonna have to simplify your answer at the end. But that's okay because you know how to do that. We have those skills. We're fine. We can do that. So we're going to take a look at using the least common denominator versus using what I'm going to call a quick common denominator, where you multiply your denominators. So 4 times 6 gives us 24. So if we use that quick common denominator, let's go ahead and solve this guy. I'm going to multiply by 6/6, and I get 6/24. Multiply this by 4/4, and I get 4/24. We're adding. This is 10/24. That's a great answer. It's not perfect, though, because it is not fully in simplest form. So we need to simplify this. They're both even, so I know they're both divisible by 2. And we get 5/12 as our final answer. Now let's see what we get if we had used twelfths right to begin with. So if we had found that least common multiple, and we've got 6, 12, 18, you got 4, 8, and 12, boom, that's your least common denominator. So I'm multiplying by 3/3, I get 3/12. Here I'm multiplying by 2/2, and I'm getting 2/12. I'm adding them. Bada bing, bada boom, I got there in one step and I didn't have to simplify. So this is the one extra step that you have to take. But guess what? You have the skills to take that step. So if you want to, by all means, go ahead. Just make sure you're really careful and make sure you actually do simplify it. All right, I'll do 2 more examples with you, and then I'll let you solve the last 2 on your own, and you can check my completed copy of notes to see if you're correct. So we have 3/5 plus 1/6. Let's go ahead and set up the stage. That's a multiplication symbol, sorry. For our fraction flag. So 30ths will be our least common denominator. Multiplying by 6/6, that's 18. Multiplying by 5/5. We're going to add these up. We're just going to add the numerators. And that gives us 23 30ths. And there's my fraction flag. That's my final answer right at the bottom there. One more together, we've got 3/8 plus 1/3. Again, if you need to write out those multiples, there's nothing wrong with that. So I've got 8, 16, 24, boom. I know that's divisible by 3. So that's going to be my least common denominator. Multiply this guy by 8/8, this one by 3/3. I get 9/24. Here I get 8/24. Add those up. We're going to add up our numerators. And we get 17/24 in our nice, neat fraction flag.